Hey everyone, and welcome to Your Desk University. I'm so excited today to be learning about robots with you. Are robots going to make construction on Mars possible? These speakers might be able to answer that question as you have the opportunity to ask them yourself in the chat. Go ahead and use that to interact. I won't be hosting this today. Jared will be. I'll intro him in a second. My name's Tim and Hazel, and I'm Senior Technical Designer at Walter P. Moore. And this week's been really big for Your Desk. Did you notice for now the interim background that we're working with? My studio is moving, my wife and I are moving, and still haven't figured out. If you have any ideas on what to do with this blank empty space, I'm all ears. Definitely join us on Slack. You can find our channel on our website, yourdeskuniversity.com, at the very bottom, and that's a great place to interact with the speakers, with other participants, and myself. Also, we were on Trexel Podcast, and I'm so thankful to Evan for hosting us there as we talked about Your Desk and the origins. It's been just under a year since we started these, and it's been incredible to do, I think, 33, 34 episodes now. I personally, as I was listening to it, really enjoyed the last 20 minutes, so make sure and check those out as well. And I know you're here to hear about robotics, so I don't want to take any more time. And with that, I will intro Jared. Jared Freeman is a senior technical designer at Walter P. Moore as well. And he and I have that privilege of working together, and it's great. And he's going to be sharing and introducing our speakers today as they talk to you more about robotics and the reality of where they are today in the industry and where they see them in the future. So with that, Jared, thank you. I'll let you take it off and intro our guests.
Great. Thanks, Timon. So as is kind of obvious from the title of the talk today, Building with Robots, it's fairly self-explanatory. But, we're going to be discussing the different technologies that people are currently using in the field and where those technologies are headed. But we'll also be discussing, how more broadly, how AEC companies can position themselves to be able to use these technologies and, different kind of business models that people are seeing and how they're implementing robotics into their workflows. So without further ado, I'm just going to introduce the three panelists today. And then what we're going to do is each of those panelists is going to show roughly 5 minutes of just some of the things that they've been working on or thinking about. And then we'll jump into the conversation from there. So first, we're going to have Brian Ringley. Brian is a construction technology manager at Boston Dynamics, where he oversees the use of Spot Robot and SDK for construction applications. Prior to Boston Dynamics, he was a construction automation researcher at WeWork, where he managed the construction robotics research program and contributed to initiatives in industrialized construction methods. Next up, we have Noni Pittenger. Noni is the Director of Construction Automation at Assembly OSM, where she's developing construction control systems for robotic and automated building processes. She has coordinated metrology-based construction innovation projects for Tesla, WeWork, and C.W. Keller and Associates. Her work in digital layout automation as a technology researcher in residence at the Autodesk Pier 9 for C.W. Keller won a 2019 AIA Innovation Award for Design Development and Design Thinking. And last up, we have Cynthia Brosk. Cynthia is a PhD candidate in civil and environmental engineering at Stanford University. She's conducting research under the supervision of Martin Fisher. She is now teaching the first construction robotics class at Stanford, CEE 327, for those students out there listening, where students are working in collaboration with 10 robotic companies around the world. Her research interests are in virtual design and construction robotics. Cynthia has a master's in science and civil engineering from Stanford University and an architecture degree from Universidad ORT Uruguay. So thank you guys all for joining and taking the time to speak and present today. So without any further ado, we'll move on to Brian. We'll kind of kick it off with his first set of slides.
Yeah, thanks so much for the introduction, Jared, and thanks for inviting me to be here to talk. I'm going to go ahead and share my screen here. So yeah, as Jared mentioned, I'm the construction technology manager at Boston Dynamics, where I am essentially the product manager for Spot, specifically for the construction market. Spot is a kind of generic mobility solution, an autonomous mobility solution that we found to have value across multiple industries, and my focus is on construction. And the value comes from the autonomous navigation as well as the ability for the customer to customize that robot, particularly putting on sensors that are useful to their applications in the construction space. This tends to be things like 360 cameras, thermal cameras, and laser scanners. The way that you control Spot, because part of what we're trying to do here is put something in the field that's usable by field professionals and does not require roboticists to operate, is that there's a very easy to use tablet controller. What that allows you to do is record autonomous missions, save them, and then play them back in the environment, even though there are dynamic obstacles and a certain amount of change in that environment, especially in construction sites. In terms of the customization and the payloads, we knew that we'd have to bootstrap that a little bit with the robot. So Boss Dynamics offers a number of things that you add to Spot to make it valuable. Things like pan tilt zoom cameras, an arm for manipulation, onboard CPU for uploading your own code. But there's also a lot of third-party payloads. We're working with all the major scanning and surveying companies. A lot of people put simple things like Ricoh Theta cameras on there. It's really supposed to be whatever is useful to you and whatever you want to be able to control autonomously in the context of a Spot mission. In order to let you do that, we really built out Spot and envisioned it as a platform. So there's a full SDK with sets of APIs that allow you to capture Spot sensor data, integrate your own hardware, such as laser scanners, and then integrate Spot data and capture into software applications like project tracking software. We also know that in order to have true or truer autonomy, that the robot needs to be self-charging and to be able to operate with minimal to no user intervention. So this year we released the Spot dock, which not only self-charges the robot in the context of missions, but also allows for large amounts of data download while it's charging over gigabit Ethernet, and gives you basically an always-on robot that you can dial into at any moment. So one of the questions is, why Spot today? And I think it's just part of a tech stack. There are a lot of other parallel technologies that make this valuable, including portable sensors and the emergence of better connected job sites. And why robots instead of other systems? Well, we think that people are too important for these low-level tasks and frankly can't do them in the same repeatable manner. Fixed sensors are very limited, and you can take it from me in my former job researching this, but drones and wheeled-or-tracked robots simply can't navigate around complex construction sites. This is a video from 2018, the first time Spot was on a construction site in Japan. This is the video I saw when I was a researcher at WeWork that made me furious that WeWork wasn't the first, company to be using this, and what ultimately led to us being an early adopter the following year. The platform was launched in 2019 and really kind of got going with the early adopter program in 2020. We ask all the same questions around automation that you'd ask with really any automation process, ultimately trying to figure out how do you fundamentally reimagine the building delivery process. So I just wanted to run through, kind of in closing, a number of integrations we have. The robot works with HoloBuilder for job site documentation and pinning 360 imagery to blueprints. Works with Drone Deploy. We have a partnership there for 360 video and pinning paths for virtual walkthroughs. That's also compatible with drone information that can be combined with Spot information. We've done laser scanning, first with Faro as a Foster and Partners study. Here's a little pitch for reading my article if you want to learn more about my thoughts on Spot and architecture specifically. And then with Swinnerton, we really started looking at the idea of doing this every day. If you're going to scan every single day with a robot, the opportunity there is really one of being able to track process. You're moving from scanning for due diligence once or twice during a project to now scanning is, my time's up. Now scanning is less costly, therefore you can do it every day. And if you're doing it every day, you can kind of lower the resolution such that it's optimized for automated work in place quantification, which then leads to other things with tracking. So I'll go ahead and close there so that we can pass it over to the next speaker.
Great. Thanks, Noni. I think you'll be up.
1 second. Are you seeing the screen?
Yep.
Okay, great. My name is Noni Pittenger, and I actually used to work with Brian at WeWork on some of those initiatives in construction robotics. And just, I don't know, Brian, you mentioning the beginning of Spot is like very nostalgic in my mind. So my work in construction automation and applied construction robotics is really focused around problems in VDC coordination that make me very frustrated. I think without being a high level or a really skilled engineer in any one of the VDC or hardware programming type of skill sets, I basically got really interested in project coordination from a technical side. And one of the things that really stands out to me in construction is the handoff and cliff information deficit model that we have. So this is where basically I'm describing a really broad strokes approach to how we want to organize information and how that information can support automation. But you kind of have to start from the very roughest end. So when I was working, and I work currently at Assembly OSM, which is a high-rise modular prefabrication company. And I can't share any of the work there, but prefabrication in general is trying to apply the same coordination model from manufacturing and aerospace and automotive engineering to the less rigid construction industry. So these diagrams still apply. When we look at the traditional construction coordination process and project delivery process, we see a lot of information buildup, reduction, and then sometimes loss. And then so information alone, the fidelity gets really degraded. When we look at the actual material and product that's coming through, we have incredible inaccuracy in what we are actually producing. And that's very frustrating because we start out with really good digital information and a very fine plan in 3D. And the two problems are connected the whole way through the delivery. When I was at CW Keller and Associates, we were building the interior panel system for the Coca-Cola stage at the Alliance Theater. So each of these balconies has hundreds of 1/2 inch steam bent oak stringers that are parametrically optimized for acoustic properties across the entire room. They all need to join end to end at the stringer resolution. So it was very, very precise, and it was incredibly, it was a material with a ton of deformation and deflection. So we were getting into some really big templating problems. So we had a really fine model, and then basically none of the materials would behave in a way that was predictable. And we had no way to verify the complex 3D geometry in the built environment. So we started looking at applying some existing aerospace tools. In carbon fiber layup for complex curvature, such as in airplane wings, there are some really tried and true laser projection systems that will calibrate to the surface you're trying to work upon and give you the 3D instructions laid out there. So when we are building something like one of those panels, we're going from a hybrid or a completely analog process that's downloaded from a 3D model to being able to verify every single part in that sequence as we go iteratively through so that we can track tolerance, telegraph issues. We can also use it to verify built product so that we could basically as an adapted QA/QC process. And this is important when if you can't do adequate scan verification for contractual delivery, this was a way that we could pass our panels out with assurance that they would fit. So the way this research kind of spun into how can we bring, if we're calibrating a special tool to a part, how can we start to calibrate that tool in a different context to the job site? And this is really where I got into kind of site layout automation and by extension construction robotics. So if we're looking at how a robot, whether it's a rover or an arm, is going to relate to the world, you have the same type of information going on that you are exporting between your CAD model to a projector and then verifying in the same place. So again, I mean, construction robotics works with a couple of different or many different ways that you can see and sense the world. And then you have a lot of different options of what you do with that data. A lot like what Brian was saying is what type of information and at what resolution do you want? And then what do you want to optimize that for so that you can interpret it quickly? So a different workflow that this was approaching was kind of, if we can erase a lot of the 2D processes and we can just work with the spatial coordination in a digital twin, we have a lot more options and a lot more precision, and we can do a lot more complex work. So this is just a proposal to basically keep everything within a live model and then fabricate in a job site from the live model. And this has been tried a lot in the industry, and there's all kinds of problems with it, but this proof of concept was a really big step forward for me in understanding tolerance issues in the real world from robotics. So the particular hardware stack that we worked with at Autodesk was, we worked with the scanner and multiple layers of reality capture. We had a robotic positioning system and an ABB arm, and then we had a Faro tracer 3D laser projector, and then we had our site. And this is kind of like, what are your inputs and outputs in a situation like this, and what do you expect to get? And this is basically how we propose that it would work, where you are calibrating this tool to the job site via scan and robotic positioning accuracy. This is just a quick time lapse of the robot. Basically, we modeled the as-built from the scan, and then the robot projected that as-built information back out into the environment so that we could analyze the differences in accuracy. So that gave us an understanding of a lot of compound tolerance issues, whether it was the scan, the robotic arm drift, or the projector being miscalibrated. Keep playing. All right, so you're gonna have to look at the browser, I think. So the lasers are really hard to see with the naked eye, but these are some longer exposure photographs of the geometry being projected back into the built environment. And yeah, so from there, that really just got me stuck in a rabbit hole of how to better organize existing construction practices such as reality capture and the way that we use that data, and then extending it down to just larger value propositions in terms of automation. So that's it.
Awesome, thank you, Noni. And last but not least, Cynthia.
Can you see my screen?
Yep.
All right, so hi everyone. Thanks for the kind introduction. And yeah, I'm a PhD candidate at Stanford University in civil and environmental engineering. And so a few years back, when I kind of started grad school, we noticed that there were a lot of new construction robotic startups that were kind of coming around the space. And I probably need to update this slide because there's much more today. But we realized that as these construction methods started to increasingly being prototyped and then adopted in the field, innovation leaders in construction that don't necessarily have a lot of background in robotics still had to be able to make decisions and consistently evaluate what's the impact of deploying these robots on site versus to how they know, the traditional construction methods they already use. And so we thought it was critical to answer how is the robot going to affect the schedule, the cost, and the quality on site. And then particular interest to us was to measure the health and safety benefits for the workforce, and how we can better decide what's the best project that is going to maximize the potential robot benefits, who to involve in the robot application, when and how. So to try to answer some of these questions, our research developed a robotics evaluation framework based on a literature review from the past 3 decades and also 3 case studies. So the first one was this case study in Norway from Nling, And this was actually deployed on site as a subcontractor, and we were able to capture all the data after the project was completed. The second case was the potential use for this drywall installation robot. And then finally, we were able to do 2 site tests of Dusty Robotics kind of in the early days with Mortensen in one of their stadiums. And our thesis here was that if construction companies had a consistent way to evaluate robotics according to their different priorities and for different projects, then they could make more informed decisions about the robot feasibility, and that could reduce the effort to deploy construction robots. So the way we are doing this analysis is first by kind of aligning the things that we as construction managers could decide on. So the product, the organization, and the process. So of course we can pick like which robot to use and on which project, and that has impacts from the physical perspective of the dimensions, power requirements, etc. But then we also need to think what's the organization now and who do we need to involve to work with a robot. Sometimes we need to enhance our current capabilities or do a lot of training, etc. And then finally, what's the process today and what would the process look like with the robot, so we are aware of how much in advance do we need to prepare. And then if it looks like it's feasible for that particular project we have in mind, then we can go on and evaluate the safety, quality, schedule, and cost impacts, and then hopefully provide recommendations to our industry partners that align with their main goals for that project. And so kind of taking that same approach, and we wanted to scale up the number of cases. So we developed a new course on construction robotics, which we offered this quarter, and we are actually finishing the class tomorrow. So really excited to see the final results. But the goals of the class were to contrast manufacturing and construction, because of course we know that when we take robots to the unstructured environment of construction, a lot of the problems arise, especially as Noni was indicated in terms of positioning and where is the robot in the world. We also wanted to understand what's the readiness of promising construction robots. So we assigned each pair of students a robot company or startup, and also a construction company that was interested in evaluating that particular robot. And then they used kind of that same evaluation method to provide recommendations. And finally, in addition to kind of the robots that we could find interesting in the market, we wanted to also have like a little look of where's the state-of-the-art robotics knowledge and research. So we actually also partnered in research with the Stanford Robotics Lab and one industry partner, Goldbeck in Germany, to try to also explore more human-robot collaboration approaches to robotics in construction. And one of the technologies that we're trying to deploy is haptics, to have a more intuitive control interface of robotics on the field. And in this particular project that is kind of different from the class, because we're not analyzing robots that already exist in the market, but we're trying to develop and come up with new designs for 5 particularly dangerous or repetitive tasks where we haven't found an optimal solution in the market yet. And yeah, that's pretty much where we are in the research right now. Thank you.
Great. Thank you guys all for the presentations. Those are awesome. It definitely kind of covers a wide spectrum of robotics in the AEC world. So I guess before we jump into the conversation, for those watching, I just want to say I'll be looking at the chat. I probably won't be able to get to everyone's questions. I'll do my best to try to ask questions that incorporate some of the other questions being asked. But I would also say that for those of you, if you still have a question that doesn't get answered, you can always go to the Slack channel for your desk and ask questions there, and hopefully our panelists can get to them. So with that said, I guess I want to maybe start off because we looked at some different examples, and Brian, you had kind of showed a quick flash of the article that you written on Architect Magazine, which kind of gets at a little bit, I think, what my question is. But a lot of the examples we saw were more in kind of the contractor or subcontractors being able to utilize these technologies. I imagine a lot of the people listening in on this are also coming from architecture engineering offices. So I'm kind of curious as to what like what is the value proposition that there would be for architecture and engineering firms to get involved, and what are, obviously without them kind of adjusting their business models and their mindset around things, like what are the ways in which they need to change their thinking and approach to the business and to buildings in order to better leverage it. So whoever wants to start, I guess.
Yeah, I'm happy to jump in. Yeah, I think the obvious value for Spot is primarily for the general contractor, because the general contractor is the one who's responsible for delivering the project on time and on budget. And Spot is a mechanism by which they can better run that job site with better data capture practices. I think there are opportunities both upstream for architects and engineers and downstream for owners and operators. Upstream, first and foremost, it's about the idea of enhanced construction administration through telepresence. The idea that you could conceivably log in to a robot and walk around the site and have a kind of higher level of virtual access. I think with COVID, we saw architects kind of discover a lot of virtual presence and job site tracking applications that had already grown in popularity among the GC set. Everything from open space destruction site to Hollow Builder. There were like 1,000 of them. Those are probably the major ones. But the idea that you could have this kind of physical means of getting around the job site and interacting with it, I think is an extraordinary opportunity for designers who quite often are just sitting at a computer most of the day. Only a couple people from the office are usually doing CA work or have boots on the ground, and that's even harder now with COVID. The other big opportunity here is the notion of the digital twin. Now, first of all, we could talk for like an hour about what that actually is and if that word is meaningful or not. But the digital twin is something that I think is primarily an owner asset. It's the idea that you can take 3D information and associated metadata from BIM, and then also historical construction progress information from, say Spot or other kind of job site recording mechanisms, and then tie in real-time IoT systems for things like tenant access and building security and HVAC monitoring and things like that. I think there's a little bit of confusion about what the digital twin and who's building it and where's the value, but let's just say that that's for the owner. So the architect is really delivering BIM, and then in the CA process, that's kind of it. That's where the head gets cut off. That's where BIM usually dies. So if you can move beyond the design, bid, build contract model and have shared risk, and BIM persists into the field, that's step one. Step two is leveraging mechanisms like Spot for real-time data capture so that you're getting a continuous feedback loop. You're not just taking design intent and imposing your will downstream. You're actually leaving an amount of uncertainty for the trades because they're better situated to provide that intelligence and level of resolution. And then once that work is in place, you're collecting that information back into your model through the CA process, making adjustments as necessary, such that by the time you get to the point of handoff of that asset to the owner, you actually have that 4D historical information of what happened every day, and then the owner can take that and build off of it. I think where we're at right now, we're not well positioned to deliver that model, and the question I have is the GC going to start taking on those enhanced services for the owner, or is that a place where architects can actually jump
in? In addition to, I think Brian's article, I'll also do a promotion plug for the article, is really excellently written, and covers a lot of really good architectural viewpoints and benefits. I think so. What the applications that Spot is delivering right now are very downstream. So they are performing work on the job site, and then the data can relate as far upstream as you want it to. I think in the highest value out of any type of construction robotics or automation is going to come from restructuring the way that we set up that data in the first place. So I think that basically, in general, if architects have more control and predictability, or if they have a better predictive ability to express what they're going to deliver and then deliver on that timeline, or communicate how that's going to go to everybody else involved downstream, the more business you can sell. So the The work that we used to do at CW Keller is an excellent example because basically those types of geometries are typically value engineered out of projects. And if they are executed, they are kind of problematic in their tolerance and accuracy resolutions. So anyway, just in order to implement robotics and automation, you need to be very organized upstream. And I think by organizing yourself upstream, you are setting yourself up for success in terms of being able to deliver, whether by traditional means and methods or from automation. And I really think like if architects approach constructability with automation or robotics as kind of the far horizon goal, you will be orchestrating your project in a really successful way and you'll become a leader in the field.
Yeah, I think I definitely agree with both kind of points raised. We definitely still have way too much unpredictable work in construction that robots could help make more predictable. Even in cases that we go beyond a reality capture and robots that only perform one task, so single task robots, they are capturing way more information than what we have today about that particular task. So we found that in many of the research case studies, we're actually learning a lot about how we do this task manually because the robot was tracking so much information that we could actually go with that information to the workers and ask better questions. And I think finally, like that could lead us to a sort of feedback loop into, are we planning the work correctly? Because now the robot is giving us a lot of feedback of what are the actual rates of production, and then also what is the rework. And we have really specific numbers and causes of when the robot cannot perform the task that we sometimes fail to capture today in the traditional methods. And I think kind of like the ultimate way in which that will also impact at the end of the day, also the design perspective, is that if you know in advance that you're going to work with this particular single task robot, for example, you may think like, wow, then maybe I don't want to design, if we're talking about the drywall placing robot, like want to design spaces that have full-size boards, because then that's easier for a robot to place and you don't need to have a manual operator when intervening when you have like half a panel, or or even thinking about designing with heavier materials if it's going to be placed autonomously instead of manually.
Right. Yeah, I think that's a great kind of segue into what I want to get to next, which is like, so I think a lot of times when people think construction robotics, the first thing that comes to mind, at least maybe up until recently when we've seen some of the more compelling images with like Spot running around a job site, but up until then, I think a lot of the first things that came to mind were like robots like placing bricks or like, laying drywall, things like that, where I think in reality, as far as today, what's currently the more applicable things that we're seeing on job sites, and from what you guys were showing, is really more focused on data capture and reality capture and all the different types of things related to that. So I guess I'm curious as to hearing a little bit more on your thoughts as to, do you see kind of going forward, is it that first we needed to do this first step of getting the data capture part down, and then next we'll start going into more of the kind of labor type of robotics that you were just talking about, Cynthia? Or is it that like those things there's not a ton of value there for people? I guess I'm curious to hear your thoughts on that. Oh, Noni, you're muted.
Sorry, I think it depends on the application. I mean, I think there's both ways. I really think that the future of this field is not going to be one silver bullet. Like there's not going to be one tech stack that everybody needs to have. There will be like ideal packages, like the packages that Brian was showing for consistently needed construction data capture and sensing. But basically, depending on what you're trying to design and construct, you need to decide what type of information that you need and how you want to address the built world with that. So I mean, people always make fun of those humanoid robots that are moving things around, but like it's kind of it's the natural first step to trying to reduce labor supply problems. Anyway, my point is, I think like if you're approaching it with the kind of the dumber task like we were talking about with bricklaying, like that is particularly annoying because a brick is sized for a human hand and you don't need a robot to move it. But we also can achieve materiality expressions that would not be possible with bricks given analog means. So I just think the customization is where we're really going to find what combinations are ringing true, and then what kind of coordination you need to do in order to achieve better work.
Yeah, that's a good point. There are affordances of robotics for, in theory, opening up design spaces. I know some masons that can do some things that are pretty wild, but and that's what we see largely in academia, is this idea of like, well, I want to increase the design space, which is primarily a formal game. And I think there are a lot of other ways to evaluate a building's success. Is it thermally comfortable? Is it cost effective and affordable? I think that sensing robots do allow us to form some kind of data infrastructure by which we can tie design intent models, which are not reality, with reality capture. The issue there is that what I'm seeing with customers is that you've got a kind of a 50-50 of GCs that work in BIM and GCs that don't. So the GCs that don't work in BIM are going to just be working in their sheet sets. There's a tremendous amount of AI and intelligence going into these, project tracking applications. Again, OpenSpace, Structure and Site, and the Hollow Builder all have ways of reading the semantics of a job site through imagery, being able to identify things like studs or sheets of drywall, and then quantifying work in place essentially as a markup on a PDF, which is kind of a crazy application of AI, but that's where the business need is because of the way, again, design, bid, build contracts and scope tend to work out. But for those instances where BIM does survive, that does give you the opportunity to have a 3D feedback loop. I mean, this is what we were doing at WeWork, and Noni was very involved in this, which is like establishing a feedback loop of getting your existing conditions scanned and adjusting your design model to that, such that you were actually in a metrically accurate model. But there were a lot of bottlenecks with that data processing, things that I hope Spot is now solving. And once you have that infrastructure, then I think the thought exercise is, given the fact that industrialized construction seems to be most clearly the way forward, as in we're going to move as much construction off-site as possible, what's actually still happening in the field? And that would kind of signal where we should be focusing field robotics. So that leaves things like data capture, Spot. It leaves things like layout, so like Dusty and the Hilti robot. And it leaves things like installation and finishing, like Canvas, the drywall robot. So I think a lot of the companies that have started to emerge are actually working on the right things, whether they be kind of a platform like Spot or a single task robot like some of the others. The brick example, Noni brought that up. I have a long history on Twitter of being really angry about robots stacking bricks. I think it's an asinine way to use a robot, unless it's like in school and you're just learning how to use a robot, which is like all fine and well. But I always point to I feel like robots that like print with concrete are a little bit silly, and robots that stack brick are a little bit silly. There are exceptions on both cases, don't hate me. But like, if you look, there's like a sweet spot for additive robotics. I think what Fast Brick Robotics is doing with the Hadrian X machine, which takes oversized bricks designed for the strength and placement capabilities of their robot, and then also tackles this, well-tread way of constructing with CMU blocks. I think that's a really compelling vision for how robots can automate additive. So, you just have to kind of apply a critical lens. And it's also a little bit of like speculating on, by the time these robots actually work and add value, will they be doing the types of things that we expect to be doing in the field?
Cynthia brought up a good point earlier about kind of what would the like sheet good change? What sheet good dimensional changes would we make if we were making those commodities for a robot instead of a human? And I think that brings up a really good point, because yes, you could kind of change the entire way we deal with shipping and commodities for buildings in order to just because right now we are absolutely forcing like the square peg of robotics into the round hole of how analog construction has been done for centuries. Really, I just think that the reimagine, like stepping back and looking at like why certain things are assumed is really, really interesting. One of the most interesting problems that Brian and I ran into with our kind of reality capture and layout work at WeWork was that we would use a lot of reality capture to verify and lay over our plans, 2D plans. And then basically we would say, okay, great. And then, like unupdated document sets, et cetera. But storefront layout, tradespeople would come in and would either, if they were using the correct information, we had not provided the correct lines from the plan. So even if we had coordinated it based on our assumptions perfectly for analog work, or like we were coordinating it to the degree that we could have used automated layout such as Dusty. Well, the biggest problem was that there was a huge disconnect between like what we thought we were coordinating for and what we assumed that the trade needed, and what they actually would have been using. So if, the way that you're coordinating for a robot would be very different apparently from a human, and that's only based on communication problems.
Yeah, I wanted to add a little bit to some of the examples, but I think it's, the question of what still really needs to happen on site is really key. And something that we saw even with some of our industry partners that do a lot of prefab is that you still need some assembly tasks, even if you prefabricate a lot. So of course, exterior, interior layout, a lot of really exciting things in autonomous machinery, which I think it's also really good to note. And then also kind of the interior wall finishes, floor finishes. One example that I was really excited to see was Shimisu's smart site system, which kind of combines also it has like kind of 3 single task robots, but it's also combined with the management system. So I think that also touches on what Noni was mentioning just now of we need a different way to communicate the task, but we also need to make sure that, if you have a schedule and then you have a robot that is going to perform based off that schedule, that it makes sense that you're going to go the next day and the road will have a certain plan, and that it communicates well with what manual workers are also doing in other parts of the project.
Brian just grabbed a book, so I'm excited to see. Maybe he's following up on that.
Yeah, I was like, this is a really great book. It was written in, I don't know, like the early 90s or late 80s. It's based on a lot of stuff that Cynthia is talking about. So like half of the book is about early single task construction robots done by a lot of Japanese general contractors, the same ones who like, 80, 90, like 30 years later were the first ones using Spot on their sites. But then the back half of it is about construction automation methods, the idea of having the factory at the building. And there are a couple different ways to do that. One is that the factory just kind of keeps moving up as you construct. There's also, I'm like totally blanking on who, I think it's the gentleman from Thornton Tomasetti, like the chairperson. There's also this company that's doing it like top down. So you just keep the factory at the ground floor and no one's ever going up and you're just hoisting entire levels up. So again, there's like industrialized offsite construction. There's the idea of bringing the factory to the site itself, which is like loosely termed as construction automation. And then there's both single task and platforms for construction field robots. So like a lot of emerging technologies. And I think it would be a mistake to focus on only one or the other. I think it's going to be some hybrid. Okay. Yes, holding it up
again.
You see it?
Great. Yep. Thanks. Awesome. Yeah. So it sounds like, I think a lot of what we're talking about in different ways, obviously, is getting at like, it's not really just about designing the robots themselves or whatever robot technology is out there. It's really redesigning an entire system, the ground up, and reimagining that. And like in the case with like Japan, I mean, they have a very different building delivery process that might lend itself a little bit better toward robotics than say in the US, which is very like, there's lots of decentralized unions, that there's lots of things. I know, when we were at WeWork, we ran into issues with that as well, where like from a labor standpoint, there's a lot of pushback in terms of people adapting these technologies and things like that. So I guess I'm kind of curious to hear about like how you think we overcome that, and then just to try to fold in a couple of the other questions into that question, like what are the kind of like operational like changes that would need to occur from either the owner's part or the contractor's part in order to kind of like reach that turning point Or is it just like we're kind of there's a wall we can't get around and unless the building codes and things like that change? I don't know.
I think I muted. No, okay. So you just said something along the lines of like we need an entire system change, which I totally agree with at a high level, and think is really daunting. I would really encourage anybody who wants to become a construction technologist in their career or is and wants a project, like the most interesting way to get your head wrapped around how you want to approach this is to try to replace one task. So if it's layout, if it's or replace or automate or improve one task. And as a construction technologist from either like a vertically integrated company where you can kind of talk to everybody, or from a GC or from an architecture firm, digging into the weeds of all of your assumptions about what it would take to automate that process. So we've done that, I've walked through this with like layout for walls, for drywall. Like you really need to know exactly how it's done traditionally, or like for the majority of the trade, and then you can look at, okay, what would it take to kind of exactly replicate this? But then how can we don't need to exactly replicate it. Like, since we're working with machines, how can we make it a lot more efficient? So I would just encourage people to dig in on, if you want to start working on this, the best way is, as usual, to dig in on one specific problem and really follow it to the conclusion of the thought. But in general, I think in my mind, the risk and liability structures inherent in the construction industry really make it difficult to suss out clear ownership of new processes like this. So Brian was saying, like, who owns this type of project progress monitoring, and if it's automated and getting kind of like out of scope or adding new scope, typically that can be resolved in some project planning meetings, but depending on where you want to seat that responsibility, upstream and downstream, has a really different data and planning implications. So that's my answer.
Yeah, we still don't have like BIM execution plans that fully capture all of the design computation methodologies that have emerged over the last decade. So let alone robotics. I get this question a lot, which is, how can I prepare or change my site so that Spot works? And I say, well, the funny thing about that is we're trying to make money today. So Spot will just work with how you do construction today. That's the value of like a legged robot, is that it can go into human purposed environments and it can deal with the dynamic obstacles and the change over time on the job site. I mean, that's the real differentiator. Now, that said, those customers who run lean sites, for example, like the demarcation of areas that are for personnel to move through only, where you cannot stage materials, oddly enough, that also makes life easier for a robot to move through the site. So, I mean, the lesson is, like, a well-run job site will also be a better job site for robots. I do think that again is where we can see that incremental change. I certainly don't want to wait for the construction industry to completely reimagine itself before we start injecting robots. And this is something that will have to happen hand in hand. I envision a lot of lean processes and industrialized construction methods, location services on site. So having technologies for indoor location services where it's like GPS starved, tag tracking on materials, or a lot of emerging things that will make it easier and easier to implement robotics. But again, back to the earlier comment, we need some kind of data and reality capture infrastructure from which you can, I think a lot of people's vision for how you direct the use of robots on a job site is through an intelligent model like BIM. And I think that's probably the right idea. But I think today I barely trust people to build a building with BIM, let alone use that to control a robot moving through an environment. So I think there's a lot that we still need to do to create kind of reality capture feedback loop. Models just aren't real right now, and that models are still strictly design intent. And until you have a model that is an actual representation of the physical reality of the site, there are going to be limitations in what can be done with field robotics.
I think models are also incredibly heavy. Like running robotics or automating any process is kind of like identifying the critical geometry that you need to work from. And so having a strategy around that can kind of release you from needing a full digital twin in like a BIM ideal situation.
And I think finally kind of the last bit is that we still have really like excellently trained workers that are really good at aspects of the task that for robots are still too difficult to accomplish. So I think kind of for me, what's really interesting looking at the future is to see how can we better capture the human expertise and also how we can have more collaborative robots on site that are not fully autonomous. And that's okay. We don't need always full autonomy as long as, you know, we have the human collaborating in a very safe way with the robot, and we've seen kind of some advances in having ways to capture the kind of the human motions and then translate those to robots, which I also think are really exciting. So yeah, I'm kind of looking forward to do that and to see how we can better leverage the knowledge and further train people, because I think in some examples, robots seem very frightening to some of the workers, but then in some of the cases, like when we tried the Dusty robotics on site, the current workers that would do the layout would be really happy to see the robot. And I thought that was amazing because they were like, yeah, right now we also calibrate the total station. So we have the basic skill to set up the robot. And then, yeah, it would be just knowing a little bit more of the technical background to how, you know, to stop if there's an obstacle or whatever, but they could see themselves controlling a fleet of layout robots. And I think that was really exciting to see. It wasn't something frightening. It was more like, yeah, we want this tool, we want to buy it, and we want to know how to use it.
Yeah, that's awesome. And I think it also kind of gets to a couple of the questions that were asked about just like the training behind some of the jargon that you see with like robotics and things like that. And also, I think just a good way, since we're approaching an hour here, just to, I think a good kind of thing to wrap up on would be talking a little bit more about that in terms of like how do we train the future workforce to, and Cynthia, you're obviously, you know, kind of spearheading this. You're already teaching a class currently. But like, how do we train future architects, engineers, and, you know, construction laborers too, so that they're, you know, I think the example that you said where they were kind of welcoming of the robots is maybe a little bit not what people would expect. You might expect people to be like, oh, like that's gonna take my job. I don't like get that off my job site. And there might be some of that, but I think that there's probably more acceptance, especially among like younger workforces than people might, you know, suspect. So I'm kind of curious to hear people's thoughts on just like how going forward we can better train ourselves and the kind of the labor force to work with robots.
I'd like to hear Cynthia's thoughts on that first, if I can put her on the spot.
I mean, I think to me, like we should really involve with the unions and the trade unions and also tap into what is their like training components and be able to support that with like some robot capability training. I mean, I know different companies have tried different ways. I know, for example, Canvas has worked a lot with drywall trades, and I think that's really impressive because it shows a path forward where yeah, they are not saying the robot is going to completely do the task on its own. It's going to need a person, and then what better person could control the robot than someone who is an expert at the task as well. So I think that's kind of like a good way forward from kind of the university perspective and the trying to like give some notions to the students that will be like construction managers. I think that has also been really rewarding because we see it a lot. Sometimes construction companies would try a robot and then be like it kind of gets stuck at that pilot phase, but it never becomes something that changes the process and it's fully implemented every time. So I think we also need to do some training on the, you know, quantifying the benefits and demonstrating those, how to measure it, and then also keep in mind like what is our traditional baseline, which I think sometimes it's very difficult to determine in some projects. But hopefully, as we kind of move on, the sort of next generation of construction managers will be more aware of, you know, there's certain technology, and if I need to evaluate that, I also need to know how I'm performing. And a lot of the reality capture, I think, can come there to help us out.
Yeah, I think in terms of education, I mean, the reason I like having Cynthia on this talk is like, I think that, sorry, here's my cat. Always, it's 5 o'clock, so it's cat time. Like, there's certain things that are happening in architecture schools that are very valuable, obviously, but I think it often kind of misses the point of how robots are valuable. So some of the more interesting work I've seen in this area is coming from like Stanford CEE with what Cynthia is doing. Virginia Tech has a really interesting program, again, that's on the kind of construction management and engineering side. So I think we're seeing those fields kind of lead the way with how these things are taught. I mean, architecture, I'm guilty of contributing to this, has really kind of fixated on the idea that the architect is the builder and is directly controlling machines. And I think that has a lot of pedagogical value because it gets you to kind of understand file to factory workflows and things like that. But when it gets to actually delivering buildings, it's just not the way the means and methods work. So it can be a little bit misleading if it's not framed correctly. And then in terms of the labor question, when I was thinking about where I could have the most impact in construction robotics, one of the things that was really appealing to me about Boston Dynamics was that it was a robot that's useful for the general contractor. So it kind of avoids a lot of thorny labor issues that we should indeed be discussing. And it's providing a service. It's doing things that weren't done before. You could argue that to a certain extent there were assistant supers and supers that were, doing things like data capture with like handheld cameras, but like the level at which you need that data capture to happen, like the same 50 locations at the same location at the same time every night, it's just not really something that a human would want to do, and certainly not something that they could do very effectively. So I felt like it skirted a lot of those issues. It was a unique affordance of robotics. It allows us to do something that adds value that we weren't able to do before, and it's in the domain of the GC, so it does not become a kind of trade labor issue. And I think that's something that drywall robotics companies are, they have to talk. They should be talking with labor. They should be figuring that piece out because they can definitely empower labor rather than replace labor, but that needs to be a dialogue. And then I think on the side of things like layout robotics, then you have to deal with coordination between multiple parties. So again, everything gets situated in the business model by which buildings are delivered. So I was kind of just like, I'm gonna like Heisman all of those like thorny, sticky issues and go to the kind of side where I'm adding value to the GC, because I feel like that's where we can grease the wheels. And once that gets normalized and socialized on job sites through the GC, I think that'll create a little bit more leeway for trade robotics to come through.
Awesome. Well, I think that's probably a good point to kind of wrap it all up. I think this is really, I mean, we can probably obviously keep going, but in the interest of everyone's time, we're at an hour. So I just want to thank you guys all for your contributions to the discussion. It was really interesting. I hope the people watching all feel the same. And like I said, if people wanted to continue the discussion, we can kind of ask questions and thoughts and whatnot in the Slack channel. So again, thank you guys all so much for your time. And